So let we start the lectures. Yesterday we understand the basic concept of solid state, like some terminologies and some matter of state, right? Uh, so the just like solids, amorphous solids and crystalline solids types. Some terminologies like space lattice sites, lattice plane, unit cell. So lattice means the crystals, okay, which is arranged in a three-dimensional space. So that is systematic and symmetrical arrangement of points or particles or molecules or ions in the space. It is called as crystals or lattice. And the definition of space lattice or crystal lattice, it be may be defined as like it is an array of a point or particles or ions or molecules, okay, and which showing the atoms or ions or molecules are in arranged manner at a different sites in a three-dimensional space, right? That is called as crystal lattice or the space lattice. This is a very important characteristics of a solid state, that is a space lattice, and which each points representing atoms or ions and or molecules, and it is surrounded by the other atoms or molecules and vice versa, okay. And so this space lattice, it is also called as the crystal lattice, right? The second definitions we understand, that is the sites mean the positions of ions or atom or the molecules in the crystals. So the position occupied by the points or particles in a crystals or the crystal lattice is called as lattice sites or the lattice point. And third definitions we understand the and this points or it is joined by each other with some bonds, and this is called as faces of crystals. It is called as the faces of crystals. So and the angle made by between these two faces, it is called as the uh, interfacial angle. It is called as interfacial angle, right? The third definition, it is lattice plane. Third definition, lattice plane. So the lattice planes means the point in a space lattice can be arranged the number of parallels and equidistant planes, which is called as a lattice plane. म्हणजे जे काय पॉइंट्स असतील ते एकमेकांना जर जॉईन केल्यानंतर एक असा प्लेन तयार होतोय. सो इन धिस वे द डिफरंट प्लेन्स प्रेझेंट इन अ इक्विडिस्टन्स, सारख्याच डिस्टन्स वरती दुसरा प्लेन प्रेझेंट असेल आणि असे जे असतील त्याला आपण प्लेन्स म्हटलंय. त्याची फिगर्स आपण बघितलेली आहे, राईट? सो अँड द नेक्स्ट basic terminology, that is a unit cell. Unit cell, it is a simple the smallest structural units in the space, three-dimensional space or the space lattice, which when they repeated in the three-dimensional space and results it is obtained, that is the crystals. म्हणजे एखादा क्रिस्टल कशापासून बनलेला आहे, तर छोटे 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 युनिट्स आहे, ते युनिट्स सारखेच आहे आणि ते रिपीट होत असतात. जर ते रिपीट होऊन असे एकत्र एका अरेंज मॅनर मध्ये जर असेल, तर त्याच्यापासून एक क्रिस्टल्स तयार होते थ्री डायमेन्शनल मध्ये. त्याचं एक्झाम्पल्स आपण बघितलंय, सोडियम क्लोराइड्स, त्याचा क्रिस्टल्स आपण बघितलाय. सो तो क्रिस्टल्स आपण तुम्हाला मी दाखवतोय तो क्रिस्टल्स कसा असणार आहे. सो दिस इज अ NaCl क्रिस्टल्स. दिस इज नॉट युनिट सेल. हा युनिट सेल नाही, जसा असा दिसत असेल पण युनिट सेल नाही. का? कारण इथे सोडियमचा इथे क्लोरीन आहे आणि इथे सोडियम आहे, इथे क्लोरीन आहे, इथे सोडियम, असं नाहीये. तर क्रिस्टल्स कशाचं तयार होईल किंवा युनिट सेल कशाची तयार होईल, तर ते अशा पद्धती. दिस इज नॉट ऑल्सो द युनिट सेल. हिअर इज ऑल्सो क्लोरीन, हिअर इज sodium. This is not unit cell. So unit cell means what? This is the unit cell. Here is the chlorine, here is the chlorine, here is the chlorine, here is the chlorine. All here corners having the chlorine. So this is called as the unit cell. This is called as the unit cell. So unit cell, it is a crystal lattice, is the simplest 3D arrangement of the particle which when repeated three-dimensional in the space रिपीटेड म्हणजे इथे असं होईल तर आता सेम असाच क्रिस्टल्स इकडे युनिट सेल असाच रिपीट होईल. सो दॅट इज द युनिट सेल इन द क्रिस्टल्स, राईट. हिअर ऑल्सो इथे आता काय आहे, सोडियम आहे, इथे या कॉर्नरला सोडियम आहे, या कॉर्नरला सोडियम आहे, या पण कॉर्नरला. सो ऑल द कॉर्नर्स हॅव्हिंग द सोडियम atoms, so it make one unit cell. So this type of the unit cell, it is repeated in the three-dimensional space and its maker, and it is arranged in the arranged manner, so in a three-dimensional space, and make it is a crystals. Okay, so in this way this is the unit cell. अशा पद्धतीने आपण युनिट सेल काय करतोय, डिफाइन करतोय, राइट. सो next point, that is the law of crystallography. So this is the law of crystallography. It is a branch of science which deals with the geometrical properties and structure of crystals and the crystallographic substance. आपण क्रिस्टलोग्राफीला असं पण म्हणू शकतो, इट इज अ ब्रांच ऑफ फिजिकल केमिस्ट्री और ब्रांच ऑफ द solid state chemistry which deals with the study of the geometrical properties and the structure of the crystals and the crystalline substances. It is called as the crystallography. त्याला आपण crystallography म्हणतो. So this crystallography, it is having a this geometrical crystallography, it is having the three classifications. So generally it is considered as a three classification. With the help of these three geometrical classifications, we consider the geometric shape and the crystals of the arrangement in the space, or the it is in a crystals. So this is the geometric crystallography is based on three fundamental laws. That's fundamental law or classifications called as the laws of crystallography. Laws of crystallography. So which laws? One is the law of constancy of the interfacial angle. म्हणजे इंटरफेशियल अँगल जे काही तयार होत असतील ते कॉन्स्टंट असतील. Even though the shape of the crystals will be changed, but the angle made between these two faces, interfacial faces, and that is the interfacial angle, which not be changed. It is constant, and therefore the law is called as the law of constancy and the interfacial angle. So the external surface of these crystals is formed by face and the planes. The angle between any two intersecting faces is called as the interfacial angle. त्याचा आपण फिगर इथं बघितलेली आहे. Just we see the figures. Okay. Here, just see here, right? So this is the, I just okay. Right. Here, this is the interfacial angle. This interfacial angle, this interfacial angle. This, suppose this is the theta. This theta is not changed. It is constant. Even though the shape of these crystals, these all three crystals are made up by the same substance. सारख्याच substance ने तो बनलेला आहे. पण त्याचे shape change होतात, तो angle change होत नाही. Therefore, this law it is called as the interfacial or the law of constancy of the interfacial angle. So we can define this law is given by the Steno, and it is stated that the crystal of same substance may have different shapes depending upon their sizes of the faces. आता याची साईज वेगळी आहे, याची साईज वेगळी आहे, ही साईज वेगळी आहे आणि ही साईज फारच वेगळी आहे. So difference depending upon the sizes of faces, but the angles between these corresponding faces remain constant. These two interfaces, this is the interface and this is the interface, because this interface made by these 2 points joined by the 2 points, like, so these two interfaces are intersecting to each other and make one angle that is called as the interfacial angle. And this angle it is constant even though the shape is changes the same substances, right? So this angle it is called as this is law, it is called as the law of constancy of interfacial angle. This law also stated that the shape of crystals is given substances may vary, but the condition under which the crystallizations occurs, but the angles between these faces are always constant. आता हे शेप का चेंज होतात, तर त्याची जी काय सिंथेसिस प्रोसेस असते त्या प्रोसेसच्या वेळेस हे अँगल्स किंवा मॉर्फोलॉजी किंवा शेप चेंज होत असतात, पण त्यांनी जे अँगल्स तयार केलेले असतात ते चेंज होत नाही, इवन दो व्हॉट एव्हर द प्रोसेस ऑफ अ सिंथेसिस, राईट. So there is a very important things about the law of constancy of interfacial angle. And this angle, interfacial angle, it is made measured by the known instrument, that is a goniometer. So this is one of the meter instruments which can be measure the angle. And the shape of this crystal is given as a different types of the interfacial angles. So this is the one law of constancy of interfacial angle. It is one law of a geometric crystallography, right? Second law that is defined, the law of rational of indices or law of rationality of indices, right? So अरे असं कसं काय करताय तुम्ही? हा मी एकच तुम्हाला समजण्यासाठी अँगल दाखवला. हा सगळे अँगल हे इंटरफेशियल अँगल आहेत ना. असं काय करताय तुम्ही? लहान मुलांसारखं नाही करायचं. हं. कोण लिहिलंय ते? सर बाकीचे अँगल्स का नाही इंटरफेशियल? ईच अँगल्स इट इज अ इंटरफेशियल अँगल. ओके. हे फक्त जस्ट एक टेकन एन एक्झाम्पल्स ऑफ दिस अँगल. हे दोन फेशियस आहे. त्यामुळे ह्या इंटरसेक्ट होतात. ही पण इंटरफेस आहे, ही पण इंटरफेस आहे. इथे इंटरसेक्ट झाली की हा अँगल तयार होतोय. याला सुद्धा आपण इंटरफेशियल अँगलच म्हणतोय ना. याला पण इंटरफेशियल अँगल म्हणायचा, याला पण म्हणायचा, याला पण म्हणायचं. सगळेच आहे. पण आपण एक एक्झाम्पल म्हणून हे घेतोय. ओके. एकदम लहान मुलांसारखं करायचं नाही. ओके. So this is the one law. Second law, that is the law of rational indices, of law of rationality of indices. This law also given by the one scientist, that is a Howe, and it is stated that the ratio between the intercept on the axis or the different faces of a crystal can be expressed by the rational numbers. याला आपण law of rationality of indices म्हणतो. So this is crystal structure is always described this with the reference of three mutual perpendicular axes. We know that here in the figure, see, this is the one axis, x-axis, y-axis, and z-axis, right? So it is each and every crystal structures is described with this three axes, x, y, and z. And this axis it is called as the crystallographic axis, right? So various planes in the crystals may intercept all the axes of or may remains parallel to one or to each other or each axis. आता सपोज आपण यामध्ये जर प्लेन्स आपण काय केले ड्रॉ केले, समजा सपोज दिस इज द वन प्लेन, ज्यांनी इथं आता ए बी अँड सी हा एक प्लेन ड्रॉ केला, जो की तुमच्या या एक्स वाय झेड ला ए बी आणि सी या पॉइंटला आणि या पॉइंटला तो इंटरसेक्ट होतोय. सेकंड प्लेन इथे ड्रॉ केलाय, दॅट इज अ पी क्यू आर. So this is also the intercept on the XYZ axis, that is this point and this point. Again, this point it is called as the second आहे म्हणून याला 2A, 2B and 2C. 1, 2, 3 याला 3C. Okay. So in this way we can say that it is the so this is HKL. This is HKL, right? So this is H, K and L. So these various planes in the crystals which intercept all the axes, right? X, Y and Z. So this when plane is parallel. आता हे जो दोन्ही प्लेन आहे ते एकमेकांना पॅरलल आहे, because it is present on the equidistance, right? So this law of rational indices, आता हा लॉ रॅशनल इंडायसेस का आपल्याला सांगतोय की हे रॅशनल नंबर्स असतात आणि ते होल नंबर्स असतात. सो इट इज होल नंबर्स and this planes it is present in the equidistance and it is whole numbers, and that law it is a law of rationality of indices, right? So this law is indices stated that the intercept made by any given plane, जो काही intercept इथे तयार झालेला असेल, this is the intercept, right? This is the intercept. Here is in this plane, here is the intercept, here is the intercept. So of a crystals along the three crystallographic axes, that is the x, y and z, so are either equal to the unit intercept made by the standard or the unit plane or the some simple whole numbers multiple of them. हा जो इंटरसेप्ट असतोय इथे इथे किंवा इथे, this is the intercept, it is the made by the angles, it is the equidistance. हा equidistance वर असतोय किंवा हा multiple by the whole numbers, it is multiple by the whole numbers. So This is called as the law of rational of indices. This is called as the law of rationalization of indices. कन्सिडर करा, ही जर फिगर आपण कन्सिडर केली तर या फिगर मध्ये आपल्याला काय दिसतंय, तर युनिट ऑफ स्टँडर्ड प्लेन दॅट इज द एबीसी which intercept the three crystallographic axes xyz, that is A, point B, point and C. Then if this crystals plane that is the DEF असा जर आपण एक crystals consider केला, so which intercept the crystallographic axis at HA, KB and LC. this आता इथे आपण PQR कन्सिडर करतोय. दिस PQR, या PQR म्हणजेच काय, तर हा कुठे इंटरसेप्ट होतोय, तर इट इज इंटरसेप्ट ऑन द दॅट इज द 2H HA, ज्याला आपण HA म्हणतोय, त्याला आपण KB म्हणायचं आणि याला आपण दॅट इज LC. आता हा HA, KB अँड LC हाच काय 2A, 2B and 3C. Okay. So then this ratio of intercept made by the given crystals in the terms of standard of unit cell, that is the H, K and L. So this is the ratio of HKL. आता हा जर रेशो आपल्याला काढायचा असेल तर तो कसा निघणार, A, B and C म्हणजेच काय आहे, तर याचे जे काय होल नंबर्स आहे दॅट इज 2:2:3. So this is the ratio of this ratio. It is called as the axial ratio. This is called as the axial ratio, and this axial ratio it is called as the HKL, are the whole numbers, that is including the infinite fractions of the whole numbers. आता इथे कितीही, तर जसं मी म्हटलंय की इथे कितीही तुम्ही प्लेन्स काढत जा, तो त्या पद्धतीनेच तुम्हाला इक्विडिस्टन्सला मिळत जाईल आणि तो रेशो तुम्हाला अशा पद्धतीने मिळेल. सो इन दिस वे दिस इज अ लॉ ऑफ रॅशनॅलिटी ऑफ इंडायसेस. सो दिस इज द crystallographic geometric crystallographic law. Second, then third one, this is the intercept made by various, this is third one. इथे त्यांनी रेशो आपण काढून बघितलाय, राइट. दिस इज नॉट द, आपण आताच बघितलंय. थर्ड लॉ, that is the law of symmetry, and this law is stated that all the crystals of same substances possesses same elements of the symmetry, right. Law of crystallography or a law of symmetry. The law of symmetry is stated that all the crystals of the same substances, the crystals असतील सारख्याच substances possesses the same elements of symmetry. सारखेच element of symmetry तो काय करतोय, दाखवतोय. Crystals can have 7 types of symmetry. Crystals ला 7 पद्धतीच्या crystals 7 types of symmetry असतात. But we are concerned with the following 3. So out of these 7, we are concerning the 3, that is 3 elements of symmetry. One is the plane of symmetry, second one is the axis of symmetry, and third one is the center of symmetry, right. Plane of symmetry, axis of symmetry, ज्याला आपण line of symmetry म्हणतो, and third one is the center of symmetry, that is also called as a point of symmetry. So what is mean by the plane of symmetry? A crystal is said to be have a plane, that is the it is of plane of symmetry when it is divided by an imaginary plane into the 2 equal parts of the such a crystals, or it is one its exact mirror image of to each other. म्हणजे जसं आपल्याला एखादा जर क्रिस्टल्स तुम्हाला प्लेन ऑफ सिमेट्री दाखवायचं असेल, सपोज दिस इज द क्रिस्टल्स, राईट. हा जर क्रिस्टल्स असेल, इथून जर तुम्ही प्लेन टाकला असेल तर याचं 2 भागामध्ये काय होतंय, सारखंच इक्वल डिस्टन्सला हे 2 भागामध्ये सारखं त्याचं काय होते, डिव्हिजन होते आणि हा आपल्याला एकमेकांचा मिरर इमेज तसा दिसतो. अशी जी प्लेन आपण टाकल्यानंतर जर 2 असं तयार होत असेल, त्याला आपण प्लेन ऑफ सिमेट्री असं म्हणायला काय हरकत नाही. सो द प्लेन ऑफ सिमेट्री इज डिफाइंड ॲज it is an imaginary plane by which if a crystal is divided into 2 equal parts, so one becomes it is mirror image of each other, right. So this is the called as the plane of symmetry. हा एक आपण असं सांगू शकतो. देन याच्या फिगर्स असणारच आहे पुढे, just this is the plane of symmetry. So crystals have more than one planes of the symmetry. This is the crystals, and this is divided by 2 equal parts, and this is mirror, exactly mirror image of each other. So this is the plane of symmetry. Again, this is the rectangular plane of symmetry. This is the rectangular plane of symmetry. Again, these 2 equal parts is divided by this imaginary planes, right. So this is the plane of symmetry. This is also the diagonal plane of symmetry, because this plane, it is made or it is divided by this diagonal, right? So this two equal parts is exactly mirror image of each other, and this is called as the diagonal of symmetry, right? So this is the plane which is imaginary plane, which is equally divided these crystals in to both sides, and it is exactly mirror image of each other. It is called as the plane of symmetry, and this is the different types: rectangular or the diagonal plane of symmetry, like this, right? Then next symmetry, that is the axis of symmetry, or else it called as a line of symmetry, right? So this axis of symmetry, it can be defined as this, it is an also the imaginary line, and which imaginary lines which crystals is rotate, the crystals is rotate, so that it present exactly the same appearance more than one in complete rotation. Suppose म्हणजे जर एखादी लाईन इथे ड्रॉ केली, फॉर एक्झाम्पल the line is drawn here, just see, right? So this is the one crystals, and this crystals, it is imaginary line is drawn, and this line, it's we rotate these crystals along this axis. This is an axis of this is line. So this rotation, due to this rotation, it is divided this crystals in two equal parts, and when it rotates, so the one face, एक face ही rotate होत असताना more than one, एक पेक्षा जास्त वेळेस ते जर येत असेल in a one complete rotations, that is called as the axis of symmetry. त्याला काय म्हणायचं आहे? Axis of symmetry. Okay. So in this way, this axis of symmetry we can define, right? आता फॉर एक्झाम्पल इथून जर तुम्ही हे जर लाईन ड्रॉ केली असेल आणि याला जर तुम्ही रोटेट केलं असेल, तर हा जो पार्ट आहे याला रोटेट केल्यानंतर एक कम्प्लीट रोटेशन करण्यासाठी हा एक पार्ट एकदा जातो, परत हा येतो, आणि हा एक्झॅक्टली याच्यासारखाच आहे ना. म्हणजेच आपल्याला दिसताना काय दिसतोय? मोर दॅन वन टाइम, मोर दॅन वन, एकापेक्षा जास्त वेळेत जर सारख्या फेसेस, ही सारखी फेस आहे, ही सारखी फेस आहे, एका कम्प्लीट रोटेशन मध्ये जर दोनदा येत असेल, तर अशा याला आपण ऍक्सिस ऑफ सिमेट्री म्हणतोय. अँड this axis of symmetry, it is depend upon the how many numbers of times of the same faces in comes into one complete rotation, that is called as the two-fold, three-fold, four-fold symmetry. त्याला त्याच्यावरून त्याचे काय होतात, असे वेगवेगळे टाइप्स होतात. सो ऍक्सिस ऑफ सिमेट्री कॅन बी डिफाइंड ॲज इट इज अन इमॅजिनरी लाईन through these crystals about which if the crystal is rotated through 360 degrees, 360 degree म्हणजे complete rotation, right? So present the same appearance more than once, एकापेक्षा जास्त, म्हणजे ही जी सेम साईट असेल तर ही एकापेक्षा जास्त वेळेत येत असेल. सो ड्युरिंग द कोर्स ऑफ कम्प्लीट ऑपरेशन्स, सो डिपेंडिंग अपॉन द नंबर ऑफ टाइम्स, म्हणजे किती वेळात ही फेस येत असेल, सो दॅट नंबर, सो त्याच्यावरती the crystal presents same appearance in one complete revolutions. It is said to be the possesses two-fold, three-fold, and four-fold or six-fold symmetry. So it is the depends upon. आता तुम्ही जर क्रिस्टल्स हा इथे घेतला तर हा दोनदा येईल, म्हणजे टू फोल्ड होईल. पण तुम्ही अशा पद्धतीचा षटकोन जर घेतला आणि इथे जर तुम्ही हे केला, तर सेम फेस हा किती वेळा येऊ शकतोय? 4 वेळा किंवा 6 वेळा येऊ शकतोय. सो दिस इज the called as the four-fold or six-fold symmetry. So in this way, we can say that this is the symmetry. It is called as the axis of symmetry. याला आपण axis of symmetry. For example, तुम्ही 180 डिग्रीने जर तुम्ही त्याला हे केलं तर टू फोल्ड सिमेट्री होईल. 120 डिग्रीने जर तुम्ही त्याला रोटेट केलं असेल, 120 थ्रू रोटेशन्स, that is called as the three-fold symmetry. And similarly, if you the four-fold symmetry after the rotation of 90 degree, 90 degree ने जर रोटेशन केलं तर तुम्ही त्याला काय सिक्स फोल्ड सिमेट्री किंवा फोर फोल्ड सिमेट्री, आणि 60 डिग्रीने केलं तर त्याला सिक्स फोल्ड सिमेट्री, अशा पद्धतीने त्या how many number of times of the same faces is comes in a one complete rotations, it is on the basis of that number, that is the crystals, it is called as the types of axis of symmetry, that is the two-fold, three-fold, four-fold, and six-fold symmetry, right? So this is also this is called as the axis of symmetry. Next example, that is the center of symmetry. This is also the point symmetry, also called as a point symmetry. Center or point of symmetry of a crystals is point within the crystals, such as that the any line drawn through it and will intersect the surfaces of the crystals is at equal distance in both directions. So जसं आपण बघितलंय की axis of symmetry or plane of symmetry चे type आहेत on the basis of their what is the plane it is intersect the your crystals, what is the how the your axis it is intersects your crystals. On the basis of that their types or they're classified into different types, right? But in a center of symmetry it is crystals, in a crystal it is only one. सेंटर ऑफ सिमेट्री ही एकच असते, याचे वेगवेगळे टाईप, कारण हा सेंटरला एकच पॉइंट असू शकतोय. दुसऱ्या ठिकाणी आपण याच्यावरून कारण दुसरा पॉइंट इथे असू शकत नाहीये, त्यामुळे सेंटर हा एकच असतोय. त्यामुळे सेंटर ऑफ सिमेट्रीचे types nahi hai ki we cannot be classified into the in a different types. So this is the center of symmetry in a cubic crystals, that is this center it is present one point, and that point, so any direction या direction ni line draw केली, या direction ni line draw केली, या direction ni line draw केली. So in any directions we can draw the lines through this center or through this center point. It is they equally distributed the surfaces of these crystals in two different part. वेगवेगळ्या पार्ट मध्ये जरी ते डिस्ट्रीब्यूट होत असेल ते इक्वल डिस्टन्सला ते सर्फेसेस असतात, and therefore this is called as the center of symmetry. म्हणून याला आपण काय म्हणतोय, सेंटर ऑफ सिमेट्री फॉर एनी डायरेक्शन. म्हणजे इथून तुम्ही टाकली तरी दोन इक्वल पार्ट्स होतात आणि इक्वल डिस्टन्स असणार आहे. इथून पार्ट टाकलाय तरी इक्वल डिस्टन्स असणार आहे, इथून तुम्ही लाईन ड्रॉ केली तर इक्वल डिस्टन्स. सो एनी लाईन म्हणजे कुठूनही तुम्ही लाईन ड्रॉ केली तर इक्वल डिस्टन्स असेल कुठेही. हे दोन इक्वल पार्ट आहे, हे दोन इक्वल पार्ट आहे. इथून लाईन ड्रॉ केली तरी हे दोन इक्वल पार्ट असतात. So any direction of any, so you can draw the line through the centers, it is equal distance of the surfaces. कोणत्याही साइडने घेतलं तर इक्वल डिस्टन्सला ते सर्फेसेस असतात, इकडे 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 इकडे. So this is called as the center of symmetry. अशाला आपण काय म्हणतोय, center of symmetry. So this it must be noted that the crystals can have one or more planes of the symmetry, one or more axis of symmetry, but crystals will not have more than one center of symmetry, right? So the total number of planes, axis and center of symmetry is called as the elements of symmetry of a crystals. जे काय सेंटर ऑफ सिमेट्री आहे, प्लेन ऑफ सिमेट्री आहे, ऍक्सिस ऑफ सिमेट्री या सगळ्यांना आपण काय म्हणतोय, एलिमेंट ऑफ सिमेट्री ऑफ अ crystals. So that crystals it is particularly substances always possesses the same elements of symmetry. म्हणजे एखादा क्रिस्टल्स असेल तर त्याला सारख्याच एलिमेंट्स ऑफ सिमेट्री असेल. दिस इज नोन ॲज लॉ ऑफ सिमेट्री. त्यालाच आपण लॉ ऑफ सिमेट्री असं म्हणतोय. So suppose if you consider the cubic crystals, and this cubic crystals like your sodium chloride, याचा जर cubic crystals तुम्ही consider केला तर sodium chlorides having the same crystals of symmetry, that is elements of symmetry, that is the center axis and the plane of symmetry, but so each and every crystal is the same. For examples, it is the rectangular plane of symmetry, rectangular plane of symmetry, that is 3 असणार आहे. सेकंड असणार आहे डायगोनल, म्हणजे आपण जे आपण प्रकार बघितले डायगोनल हा किती असणार आहे, तर इट इज 6. सो टोटल प्लेन ऑफ सिमेट्री किती असणार आहे, 9. देन ऍक्सिस ऑफ सिमेट्री, सो फोर फोल्ड ओके, फोल्ड किती असणार आहे, तर 3. थ्री फोल्ड असणार आहे, दॅट इज अगेन 4. देन टू फोल्ड हा किती असणार आहे, तर इट इज 6. सो दिस इज टोटल 13 axis of symmetry, 9 plane of symmetry, 13 axis of symmetry, and 6, that is the center of symmetry, it is always 1. So it is always 1. It means that the total element of symmetry for this one, that is 23 elements of symmetry, 23 elements of symmetry for the each and every NaCl crystals. प्रत्येक NaCl crystals सोडियम क्लोराइडच्या क्युबिक क्रिस्टल्सला 23 elements of symmetry असतातच असतात. So this is the crystals we can define with the help of this element of symmetry. So if you consider that the copper sulfate and hydrated copper sulfate, there is no element of symmetry. Just असं असेल तर त्याला काय नसतंय. CCM chloride ला आहे, zinc sulfate ला आहे. So in this way we can define the crystals with the help of this element of symmetry, right? So this is hence the total number of plane of symmetry, points of symmetry, or plane of symmetry, points of symmetry, or axis of symmetry possesses by a crystal is called as element of symmetry. Now, the next and very important things is the space lattice. That is the space lattice.